Hello guys, my name is Devesh Jadvani and welcome to my YouTube channel. So guys, in this video, we are going to discuss yet another important and yet another simple and exciting topic, which is called as deployment. We will talk about why deployment, how do we deploy, and we will also talk about what is CI/CD pipeline and how do we exactly achieve it. So yes, let us dive right into this. So now we are talking about deployment. Okay, what is this word deployment? What does it mean over here, and why is there a need for us to study the deployment? This is the core topic of today, and this is gonna be very, very interesting. Let me tell you. So, deployment is the process, okay, the process of rolling out your application to the users, okay, process of handing over to the client, handing the application to the user or to the client. Okay, I'm just gonna write user or client. Of course, why are you developing any application? Because you have a client request, or because you are developing a product, you are your own company, or you are making some product for some company. This is the whole idea of developing any application. So let us talk about a scenario that we are some organization, okay? We are some XYZ organization, and what do? We provide AI services consultation, or we provide AI services. Okay. Now in AI services, we as an organization, we tell that, hey, I'm just gonna draw a building to demonstrate that we are an organization. So we say that, hey, you can come to us with your business problems and we can convert that into an AI related solution for you. This is good. So now how it happened is, one day we have a client. Now this client comes to us and this client tells us that, hey, I want to automate my HR process. Okay. HR policy process. Now, why do we have to update my HR policy process? So I have my HRs. HRs have lot more important work to do. But every time we have new people onboarding into our organization, we have previous people who are, unclear about any of the HR policies. So what do they do is, all the people in the organization again and again disturb to the HR regarding the policies. How many leaves do I get in 1 year, or how many sick leaves are allowed, or whatnot. Okay, HR is fed up. HRs of my organizations are fed up, and I want a solution that, can you develop an AI solution for me which will handle all the internal employees for me? How it will work is, I will give you some policy documents, HR policy documents. This is going to list out all the details of our company related policies wherein the HR is involved. And now what we can do is, we can develop a chatbot. We can develop a chatbot who can have access to this particular database, and this chatbot can handle all the employees, so that my HRs are doing much more important work rather than answering all the requests and queries of the employees. So this is the problem, and we say that yes, we can do it. Okay, we are providing AI services and we can do it. How we will do it? We will provide you a RAG based service. Okay, we will make an HR policy RAG assistant for you, and using this HR policy RAG assistant, you can integrate this into your system, and you can run this on your server as well, or whatever domain you have, and your problem will be solved. Then no employee will come to your HR. They will directly talk to the chatbot for any questions. Now, deal is done, deal is onboarded. Now, what is our task? To develop the application. Okay, so to develop the application is the task. And what all things come into development? First, we have to do some experiment. So we do some experiments in a Jupyter notebook, IPY files. Once we are done with the experiments, that experiments are working. Okay, what exactly did we do in our experiments? We did two things. We made data ingestion pipeline and we made data retrieval pipeline. Done, experiment working. Now what we did was, we made a modular structure program. Okay, wherein multiple files were created to have a modular like structure, and all the logics were called in the main file, and we develop a modular structure program. So this was working as well. Okay, then we went on doing some more developments on top of it. We migrated from a local database to a cloud database. So local to cloud DB, this is what we did. Then we also added the most important part, that once the application is ready, application is working, we added a UI to our application. Now anyone can start using and testing our application. This is also good. Once this is done, while we were testing our application, we found out that people can bypass our application, people can fool our AI, because in the end it is a AI, right? And we are humans. So what we did, we added LLM security. And after adding LLM security, adding observability, adding guardrails, adding gateways, we were done. Our application was secured. Once all of this was done, we also took an exam of our AI application, which means we also evaluated our AI applications to check how it is performing. And once we took the exam, we understood that our AI application is performing absolutely good. Okay. And yes, now we are done. We are done with the entire development of our application. If I show you how an end-to-end product looks like, I'm just going to go here. And any product you talk about, any particular application you talk about, I'm not talking about an AI application, I'm talking about a generic software. Any software application you talk about is going to consist of both of these components. One is going to be the front end and second is going to be the back end. Okay, so how it works is, front end is the user facing part. This is something that user will be using. Okay, the user will simply search on Google, the user will use the YouTube. They don't know what is going on in the back end. Okay, if I just open this is a tab, right? If I press F12, okay, so something is going on in the back end over here. I'm just showing you something is going on in the network side, something is going on in the back end. Okay, actually this is the front end side, but I'm showing you that people don't care about all of this, what's going on behind. People just want to use the application, and that is what the whole purpose of front end is. That, hey, I want to just use this application, that's why I'm coming for you to take the service. I just want to chat to this chatbot. I don't want to know how it is using its logic. So this is the whole purpose of front end. And in our application we have used Streamlit to create this front end. Front end consists of two things: UI, which means the interface which people use. Now, UI is a very big component because people tend to use our application more if it is much more friendly to your eyes, right? Now look at this feature. I'm drawing this line and this line is disappearing. This is so interesting, right? Instead of me scribbling over and erasing it, instead of this is so simple. So this is the component of UI, and such small components of UI, increase the traffic. Okay, that is why we have a big dedicated teams for UI. Now, functionality. UI is one thing, that how does it look? Functionality is other thing, that what all things can we use it. We can talk to the chatbot, we can use Google Lens, we can have a voice typing feature. So these all are functionalities. Okay, so UI offers us two things. Front end offers us two things: UI and functionality. Currently we are not learning front end at all. Okay, we are not front end developers. We are developing AI applications, AI use cases or softwares. We are only concerned with back end. Yes, we can make front end. We use coding agents for making front end. Okay, in a office or a real world organization scenario, we have a dedicated front end team who works on these applications. What are the technologies that people use? People use React, HTML, Angular, JavaScript, CSS, TypeScript, Tailwind. Okay, there are many front end technologies which people use, and we are not going to learn any of those. Okay, so how this works? We know that there is a front end, and there is something called as back end as well. Now we are the people who are developing the back end. What does this backend have? First of all, backend is running on a server. What is a server? Server is a machine. Okay, for our sakes, our computer machine is only our server where we are running the application. In the organization scenario, we will have a dedicated server of the organization which would be running, and we would be accessing those resources. What all components come into a server? Storage, RAM, okay, networking, right, internet access, all those things come into a server. You can have a simple Google search, okay. I don't want to bore you guys. You can just simply Google search what is a server in simple words, okay. It's gonna tell you a computer software or program that stores your data and share it with other computers called clients over a network. Simple, okay. We can also connect our computer via ethernet or something, and we can of course share our data from our server. And similarly, on one server we can run multiple computers as well. That is not a problem. So what we are doing on this particular server, which has some storage, which has some network capabilities into it, we are running our application. So this is the same thing which we used to do. Streamlit run your application. So we used to run our application on our server, which means on our computer machine. Now our application is running, okay, our backend is running. What all things are there in the backend? In the backend there is a pipeline running, okay. What is this pipeline exactly? This pipeline is to run this functionality from the UI, which means you will press some button on the UI which will trigger something in the backend, and backend will do something and send you back the response, okay. So backend contains two things. First is the core logic of the functionality, which means this search functionality is working here because there is some logic written in the backend, okay. That is how it is running. So backend contains one thing, core functionality of the logic, and second one, database. Every backend, of course, and always in most of the scenarios, in the real world scenarios, does contain a database, okay. Now if we talk about Amazon is going to store product information, right? And if we talk about our project, HR policy rag assistant, we need a database as well, which is vector database in our scenario. Now that can be cloud or local, whatever, but database will always be there in an application. All right. And how it works finally, the moment you press a button on your front end, a request is going to be sent to the backend. Backend is going to run some logic to process that request, and once the logic is written, the logic is done, it is going to send a response. So similarly, if you have a UI, okay, if you have a UI, Streamlit UI or whatever UI, you can send a query, hey, how many sick leaves do I get? The moment you write this question, this request is sent to the backend. The backend is running a RAG pipeline, okay, retrieval augmented generation pipeline. There are two things which comes into a RAG pipeline. We already know, data ingestion and data retrieval. So data ingestion pipeline will store the data in the database, and the data retrieval pipeline will fetch the information from the database. And that is what is the core logic of the backend, okay. And this is not any software, this is not just RAG, this is any particular software it exists in this world, okay. Everything and anything is made in this way itself, okay. And what I am talking about here is an end-to-end application, okay. End-to-end application which contains a front end and a back end, okay. Now why are we even understanding what is end-to-end project? Because we have to develop these projects, right? That is why we are understanding this. Now we know how a end-to-end project is made, and we have also made one project wherein in the front end we have used Streamlit, in the back end we have used Python. We can use different languages, C language, JavaScript, sorry, not JavaScript, Java, C++, Python, Node.js. We can use all these different kind of programming languages in the backend. For AI world, mostly Python and Node.js are into the picture. We don't really use Java and C++. Yes, they were used initially in the legacy systems, but now we are totally using Python and Node.js. And Python has a bigger community, the biggest community in the AI field. And our backend is running in Python. Our database is quadrant vector database, and the logic is our RAG logic. To write the logic, we have used LangChain and many other things. So this is the entire end-to-end project development which we are done with. Okay, why am I stressing over this so much? Let me talk about this. Okay, now when we talk about development happens in two stages. First, okay, I'm saying stages. First stage of development is local development. Let me use a different color. Local development. Okay. And the second stage of this development is cloud development. Okay. Let me take this. Cloud development. So that is why we have cloud engineers as well. Okay. Now, every application which you will be developing, first you will develop it on local. That is it working on my machine at least? Okay. If it is working on my machine, then I will figure out a way that how I can run it on all the machines. Because see, let us talk about Instagram. Someone in the world made Instagram on their computer. Okay. On their computer, it was working. Now what they did, they took this application to cloud. Okay. They took this application to cloud, and using cloud, they made some link, and people can access this link to use Instagram. Okay, this is what they did, which means every product lifecycle has two stages of development, which is local and cloud development. So local development is called local development, but cloud development has a specific word, and cloud development is also called as deployment, because now we are done with the development. Now application is working. Now the only concern is how can my users, how can my customers use my product. So that is called as deployment. All right. Deployment is the process again wherein we are rolling out our application to our users to use it, or our client to use the particular solution which we have developed, and this is deployment. Okay. Now, let us understand more about this, how it works, and what is cloud exactly. So, cloud. Okay. Before understanding cloud, let us have a simple scenario. Okay. Now, you have a car. Okay. You have a car. I'm going to take a very simple scenario. You have a car. You use this car for traveling. Okay. And to travel, you need a few things into this car. Petrol, of course, right? And you need some oiling and maintenance and everything. Okay. So we can say that petrol and oil, etc., this is the electricity of car. Okay. Car is powered up because there is petrol and all these things into it. Okay. Now let us say you have only one car, and you have three friends only. Okay. You have one car and you have three friends. Okay. You all are happy, everyone is happy. But what if now you have 15 friends? Okay. Then what will you have to do? You will have to get, okay, you will have to get five cars. Car into five. Why? Because your friends are increased now, and now we don't need one car, we need five cars. Okay. So earlier we were filling the petrol for one car. Now we have to fill the petrol and maintain the petroleum system of five different cars. Okay. If this car is going bad, or something is happening to the car, it is me who is responsible on, uh, fixing this car. Okay. Similarly, same scenario. Earlier, earlier you were only three friends. Okay. And you did not have a car. So what you did, you rented a Uber. Later on, what happened? You rented one Uber. Later on, what happened? You are 15 friends. And now you guys rent five Ubers. As simple as that. Okay. So I'm trying to explain you that even if you own the car, or even if you rent the car, your work can be done. Okay. This is what brings us to cloud. Now, when we are developing the application, okay, we are running it on one machine. Okay. We are running it on one machine. One machine can handle, let us say, 1,000 users at one time. But with more users coming into the picture, your machine will start to give latency. Your application will start to work slow. Okay. Your application will slow down because your application has some power, some capacity. Just how this car, okay, this car had a capacity of four people or three people. So similarly, your machine, your own computer machine, whatever you can call it, that also has a capacity of 1,000 users only. In this scenario, what can you do? In this scenario, you have one machine, right? And what we understood about the server, okay, a server is something which has, a storage. Okay, let me write it. A server is something which has storage, which has a RAM, okay, or which has networking. So if this server is highly powerful, we can run not one, we can run 5 computers onto this server. Okay, 5 computers onto this server, which is absolutely fine. Okay, but now, okay, 5 computers are running, but the scenario is these are my servers, this is my computers. If any of the computer is not working, again, why do we need multiple computers? Because on one computer, we can only manage 1,000 users. But if we have 4,000 users, so every computer can handle 1,000 users. Okay. Now, let us say if 2,000 users are gone. So we will have to remove these computers on our own. Okay. So what I'm telling you is, if you are managing this on your own, your computers, you will have to increase your computers, you will have to decrease your computers, because user traffic keeps on increasing and decreasing. Okay. You will need a network engineer. Okay. You will have to manage your servers. You will need dedicated data centers. Okay. Let me show you how this server rooms of organization looks like. Okay. I'm going to go here and I'm going to show you data centers from inside. Okay. See, data centers from inside. This is how a data center facility looks like. Okay. What are all these? These are bunch of computers running concurrently together. Such a powerful system. See, so many computers are running. See, these all are computers, stacks of computers running. Why? Because we need high power. Why do we need high power? Because there are high number of users coming to our application and we have to manage that. Okay. Now, where am I taking this towards? If you are an organization and you have this product wherein more users are coming and you have your own computers, so you are the person to manage your own computers. Okay. And this is called as on-premise. This is called as on-premise solutions, which means your product, your application, you are running it on your own premise, which means you will need a room. Okay. You will need a physical storage, and in physical storage, you will have to manage your own machines. Okay. This is on-premise solution for deployment of your application, which means now you have made your application. Now you want to give it to users. So the first solution is on-premise solution. Second solution is cloud solution. Okay. So just how when the number of friends increased, what we did was we rented 5 Ubers. Similarly, what we can do on the cloud is, what do we get on the cloud? We get resources. We get, let me be very precise, we get computing resources on the cloud. Okay. And what all things are included in these computing resources? Computers, basically, virtual machines, we call it computers. What is a virtual machine? Currently, I'm using my computer. This is a physical machine. I can use a computer over internet as well. That is called as a virtual machine. Okay. I can also get storage. I can also get, networking options. I can also get SQL on my cloud. So everything I can get on the cloud. I can rent all of that. Okay. If I was not renting that, I have to maintain my own SQL servers as well, my own data. I have to manage my data. Okay. So this is what cloud is. Let me go here and do a random search. What all resources do we get from cloud in simple words? Okay. So cloud computing give you powerful computers, storage, and software over internet instead of buying your own physical hardware. Okay. This is the whole point. You don't have to manage it. Someone else is running there. Okay. So you might be thinking that everything is on cloud, which means everything is over internet. Okay. It might be in internet for you, but for the specific organization, it is still running a physical storage. What do I mean by that? Let us say AWS or Google provides us cloud solutions. Okay, we know that we have Google Cloud and we have AWS Cloud. They are giving us to use storage, hardware, RAM over the internet. Okay, this is good. Via internet, we can use all of their resources. But they are running these resources physically somewhere. Okay, please understand this. Physically somewhere, all of these resources are running, and that is what is called a data center. Okay, that is what is called a data center. So if I show you Google data centers, okay, so see, Google data centers are spread worldwide. Okay, this is how data centers look like. These are physical machines running so that people over entire world can use it. Okay, Google data centers in regions. If I show you something like this, so see, these are all the places where the Google data centers are located. See, so there is not only one facility, there are so many facilities where Google data centers are running. Why? Because the world is using Google hardware. So Google is running their hardware somewhere physically, and we are using that hardware via internet, and this is what exactly is cloud. Okay. So instead of you running your application on your own computers, you rent your computers from cloud. Why is it so good? Okay, because cloud will manage it on cloud's end. If there are 1 lakh customers, okay, if 1 lakh customers are using your application, cloud will automatically increase the number of computers to 100. If only 20 people are using your application, cloud will automatically reduce the number of your computers to 1 computer. Okay, similarly, renting a car. So let us talk about this funny scenario. Earlier, you were a person and you had only 3 friends and you got 1 car. Okay, then what you did, your number of friends increased and now you have 5 cars. Sorry, 5 cars. Now 5 cars, everything is working good, and one day those people are not your friends anymore, but the car is still there. Okay, friends are not there anymore, but the car is still there. You bought the car. What will you do with the car? Similarly, when you are running your application, earlier 10,000 people were using your application, but now only 2,000 people are using your application. But you still have those computers bought in your physical space. They are costing you something. Okay, so that is not good, right? That is a loss for you. So you don't need it. So you only use the machine and you rent it. Similarly, if we talk about the Uber scenario, if the number of friends are reduced, so instead of 5 Uber, we will do 4 Ubers. Okay, as simple as that. Nothing costed us a lot. Okay, we did not went through any losses. Similarly, it is the case that if you have a on-premise deployment solution, okay, you are going to bear all your cost. You have to manage all of that. Okay, but if you are using a cloud solution, the cloud provider will manage all of that on their end. They will make sure that if you are not using the machines, shut them down. If you don't need them, automatically compress the machines, increase the machines. So that is the whole purpose. We need cloud solutions to deploy our application. And one last time again, why do we have to deploy? So that we can give our application to the users or our clients to use. So now we clearly understand that when we need on-premise and when we need cloud solutions. Mostly already established organizations go for on-premise solutions because they know how much the compute they need. But newly startups or now the forward-moving people and the new generational organizations are adapting to cloud solutions because that is the best option, because you don't have to manage your own resources, right? And this is what takes us to cloud computing. Let me go here and let us understand something about cloud computing. What is cloud? Cloud is renting you. We are just understanding it here. Cloud is renting you the computer storage and software it built for itself. Let us say search YouTube, Gmail, so you can build your own application on the same infrastructure without buying a single server. Okay, this is same like an Uber example. We know this. Why does it matter for AI engineers? Because we need powerful GPUs on demand. Okay, we don't know when do we need it, but whenever there is a demand, we need it. We need huge storage for data and embeddings, because let us say there are GBs of data and we want to store it in vector database. We need huge storage for that. We want to scale up and down, which means now scaling comes in two things: storage scaling and user scaling, which means your storage can also increase over time over GBs and TBs, and similarly your users can also increase over time in thousands to lakhs to crores. And for cloud, again, you only pay for what you only use. So this is why you go for cloud. Now this is the most important part. Where am I taking this towards? Is cloud service models. Okay, currently there are three leading cloud providers: AWS, Microsoft Azure, and there is Oracle Cloud as well. There is GCP as well. Okay, now AWS is by Amazon, Microsoft Azure is by Microsoft, and GCP is by Google Cloud Platform. So let me go here and talk more about cloud computing first. Okay, there are three things which we have to know when it comes to cloud computing. So let me go ahead and start talking about that. Cloud computing. Now these are the basics of cloud computing which everyone should know. So I'm taking it a little bit slow over here. There are three things coming into the picture when we talk about cloud computing. First is platform as a service, software as a service, and infrastructure as a service. Okay, infrastructure as a service. All the cloud providers which I just said, AWS, GCP, and Azure, they all give us these three things: platform as a service, software as a service, and infrastructure as a service. Let us break this down and let us understand what exactly it is happening. We know Google and Amazon are big organization. Google and Amazon and even Microsoft, these are big organizations. Okay, and they want high number of hardware. They want heavy hardwares to run their systems, because entire world is using Google and Amazon. So of course they will need a lot of things. So similarly, for managing their traffic, they built data centers for themselves. Okay, they build huge data centers for themselves, for running their own resources, for managing their own traffic. And what happened is, they thought that why not we can give this to the people to use as well. Okay, what they have made is, they have made data centers wherein they have servers running. Okay, and people, they thought that why not share this with the entire world and also charge them as a business model. Okay, like a business strategy. We have made these servers now. Okay, we might or we might not need all of them, but what if we share with the people in the world, and they can let us manage the infrastructure, since we are already managing. So this is what the first part is: infrastructure as a service. These guys made data centers for themselves, but with the world evolving, they also started sharing them with the people as a business strategy. Okay, so this is the first thing which brings to us infrastructure as a service. All the cloud providers and cloud platforms gives us infrastructure as a service. Infrastructure involves renting computers, renting machines, and renting all the network and all the resource related things. So this is infrastructure as a service, IaaS. Then secondly, platform as a service. Okay, so now one way you can access this is via using your network. Okay, via networking access you can use it. Okay, if you are a network expert. But what if you are a beginner and you still want to use a cloud machine and you still want to use a cloud solution? So they are also giving platform as a service. What is platform? Literally the console, or the the page, the console page, or the main page where you use GCP page or AWS page, right? If I just simply go over here and if I open one of my accounts, so I'm just gonna go here and open GCP. Okay, GCP, this is the console. Okay, what is opening in front of us is the platform which we use. Okay, the platform which we use. See, we can create a new project from here, and on the left hand side we can use all the different Google Cloud resources for security, for storage, right, for using AI agents. So I can simply open this as well. See, and we can use the agent platform of Google as well to do whatnot. See, we have something called as agent garden, wherein interesting things come into the picture. So you can use all the services, databases, right, virtual private networks, monitoring, which means observability, all in one place. They are saying that everything that you need we will provide you. Okay, we will provide you cloud solutions. This is platform means they have made a dedicated place where you can go buy, use the UI and do something. If I go to billing, okay, and if I search something over here, so I can see how much I have spent till now, how much is the cost I have spent till now, right? If I just open like this, okay, if I just open a project, and we can see manage billing accounts. So cool, we can add a billing account, of course. This is currently stopped, but yes, platform as a service, using their platform to use their own services, so they are giving us, right? Thirdly is software as a service. They make their own softwares, right? So if we talk about Google Cloud has made Vertex AI. Vertex AI is their agentic platform, which means just how we have LangChain, LangGraph, similarly we have Vertex AI to make AI agents. We have Vertex AI Studio to make no code AI agents. Similarly, by AWS, we have AWS Lambda. Okay, I'm just saying that some softwares. Google also lets us, if we talk about Google also lets us use their Gmail, right? Gmail API, Excel API, right? Calendar API. We have seen those bots which automatically reply on your on behalf. We have seen those AI bots which manage your Excel sheets. We have seen those bots who, given a message that, add a meeting appointment, add a meet appointment at 5 p.m. with XYZ person on a Tuesday. Okay. So if you just give this prompt via your Telegram, internally some logic will run and automatically it will update the same in your Google Calendar. So they are also giving their own made software to us to use. Okay. And this is called as software as a service. So every cloud offers us these three things: platform as a service, software as a service, and infrastructure as a service. Similarly, Microsoft has made their Foundry models, okay, their agents, so we can use their software as well. This is what software as a service. And every cloud provides us these three things itself: infrastructure as a service, platform as a service, and finally software as a service. As simple as that. Now, how does it work? Okay, how does this entire thing works? Now let me tell you, very simple. This is very important and the most interesting part. How does this work? How do we run our applications on the cloud? See, you made an app, you took this application on GitHub, you stored your application on GitHub. Okay, and what you can do is you can just go to your friend's computer. You can clone this particular application on your friend's computer. You can install the requirements and you can make the virtual environment, and that app will be running on your friend's computer as well. Okay, friend's computer as well. Similarly, cloud also gives us computers. So just how I went to a friend's computer, I can go to a cloud computer. Okay, a computer over the internet. I can go there, I can clone my GitHub repository, okay, and I can run my application there as well. And once I'm running that, the cloud will give me some network link which I can add to the domain, and my application will be up and running. This is the most oldest and the most simplest way of running your applications on the cloud. Just clone your GitHub and do it. But what if there are new changes in your system? Because processes are agile in nature, and every day we are making new developments. With the advancement in day-to-day life, we are advancing our software as well. So what if we update our application? So we will have to go to all the computers, okay, whatever we have made. Everywhere we'll have to get the new changes. We have to pull the new changes, and then everything will be good. But how many times will you do it? Okay, you will be fed up by again and again making the integrations and then pulling it on all the computers and managing all of that. That is not good. Okay, so that is why there is something called as CI/CD into this word. CI/CD stands for continuous integration and continuous deployment. Okay, continuous integration and I'm gonna write here continuous deployment. So this means something like this. Okay, infinity loop. This will never end. Life will change, people will come up with new updates, planning, requirement gathering, making new integrations, developing it and pushing it to GitHub. Then the GitHub changes will automatically be pulled, deployed, monitored, maintenance, and again the loop: planning, requirement gathering, development, and deployment cycle. So this is an end-to-end loop, and this is what is a CI/CD pipeline: continuous integration and continuous deployment. How does this work? This is the most interesting part. How does this CI/CD pipeline work? Okay. How it should work is I will give you a 1000 feet overview information. Okay. So simple. You made an app. You pushed it onto GitHub. Okay. And your application is running on cloud as well. The moment it is detected that, hey, there are some changes on GitHub, this app will be rebuilt automatically. Okay, automatically the changes will be pulled, the app will be rebuilt, and then the latest app will be running online. Okay, this is the whole idea, high level 1000 feet idea of CI/CD, that you make some changes, you push it to GitHub, automatically the new changes would have been reflected on the cloud. Now let us discuss CI/CD in depth. How does this work? There are a few things which we have to know before this. There is something called as Docker containers. Okay, we have to understand this word. Very important concept, very interesting concept. Docker containers. Okay. Now how this works in much more depth. We make our application. Okay, and this application, what we do is we push it on GitHub. That is also there. And whatever our code is, whatever our logic is, we write a Docker file for that. Okay, I will talk about Docker, what it is and everything. We write a Docker file for that. What Docker file will do is, Docker file will take our entire application and run it in a container. Okay, in this our Python app will be running. Okay, I can just make some okay, not the best way of, let us say our some application is running. I have just made this random application. Let us say this is some random application like this. Okay, and this is running. So Docker will run our application in a container, and this container can be built 100 number of times. So if there are new changes, Docker will rebuild this particular container, and this is the container which is running on the cloud machine. Okay, now this is much more in depth. Okay, now let us understand Docker in much more depth. Okay, so Docker in simple words, Docker, you can compare this to the cup noodles which you have. Okay, cup noodles. I would love to take that analogy. Let us go and see how cup noodles look like. Okay, I will go here, cup noodles. Okay, this is how cup noodles look like. Okay, so I'm here and I'm pasting this cup noodles right here. And similarly, I will paste one more thing. I will just paste packet. Okay, I will go here and I will copy this and I will paste it over here. So let us understand an analogy. Now you are a chef. Okay, you are a chef. You are an expert in making this Maggie. You have a specific recipe. Okay, you have a specific recipe and you have some steps to make this Maggie. What happened one day is you called some of your friends home and you served them this Maggie. Okay, they all loved it. They all started asking you that, hey, please tell us your recipe and we will also make the Maggie. So what you did, you wrote this recipe on a piece of paper, you gave it to them and you told them, hey, go at your homes and go ahead and make your Maggie. Okay. But what happened is, in reality, when all of your friends went home, this guy made some another Maggie, this guy made some another Maggie, and this guy made some another Maggie. Okay. You did your part well. You exactly told them that how do you make your Maggie, and uh, and they went with ahead, and but they could not make the same Maggie as you. Okay, this is what used to happen earlier, because there used to be two teams. There used to be a development team and there used to be a operations team earlier. Okay, development team used to take care of developing the application. Okay, and operations team used to take care of deploying the application. Okay, deploying the application, which means they used to take care of the networking side, the server side, everything, and these guys used to take care of the programming side. So a very big concern, a very big problem had raised earlier. This works on my machine. Okay, this works on my machine. How it used to happen is, developers used to make the application and it used to work on their machine. But when they used to give these people that, hey, go, now application is ready, go use it, these guys, these both of these development and operations team, they used to have continuous fight between each other, that, hey, you have made some mistake. Deployment team will say that you have made some mistake. Application team will say that, hey, it's working on my machine, you have made some mistake. So let us go and look at a meme. Okay, let us look at a meme. This works on my machine meme. Okay, I love these memes. Okay, so let us look at what this meme says. It works on my machine, then we will ship your machine. And this is now how Docker was born. Okay, so see, that is where I'm taking you towards. This all comes into memes. Check this meme out. Okay, this code doesn't even build. This operation guy says, he's saying build successful wasn't listed in the sprint requirement. Yeah, this is not the best joke, but similarly, we have a lot of memes of this works on my machine meme. See, before DevOps, it works on my machine, it works on my container. So we are understanding that things are different, and this works on my machine was a real, let us look at this. This meme looks little bit funnier. Let us see. So this code doesn't even build. It works on my machine. See how angry this guy is. Then we'll ship your machine to the client. So understand, see, he's saying that this is working on my machine. So he's saying that we'll take your computer and give it to the client, as simple as that, right? So this was the kind of seriousness this problem had. And that is the whole reason this Docker was born. What Docker does is, let us understand this example now. Now, this was a problem. This is the solution, containerization. Containerization of your recipe. What this will contain is, it will contain the right amount of noodles. Okay. It will contain the right amounts of spices. Okay. Right amount of spices. And it will contain the right steps to make this. Step is simple. Just pour half cup of water. Now people cannot go wrong over here, pouring half cup of water. Here they can go wrong in terms of spices and the processes. Here they can never go wrong. Okay. And now you just pour half cup of water, and all the three friends, and not even three friends, 1,000 friends, everyone will get the same taste of the Maggie, because now we have a container. Now we have a process which can be replicated in a much more simpler manner. So Docker was an amazing solution. You can watch some more videos on YouTube for understanding Docker in much more depth. I have kept it really simple. And this is how it works. Okay. You made an application, you wrote a Docker file. Docker file is going to copy your entire code base and it is going to store it in a container. Okay. This is a container. Now this is just a container. Similarly, this is also just a container. To power up this container, this particular container, you have to pour some hot water in here. Similarly, to power up this container, this is just an container which contains the code. To run this code, you need a cloud machine. Okay. And once you use the cloud machine, on top of your cloud machine you run this container, and that is how now your application runs. And this is entirely called as CI/CD pipeline, continuous integration and continuous deployment, wherein the moment you push your code on GitHub, okay, it will build a new Docker file, and this new Docker file will be running on your uh, cloud computer. As simple as that. And yes, this is the entire process of deployment. We will go in much more depths. Okay, talking one last thing, talking about cloud. We use cloud, okay, we use cloud because cloud gives us something called as cloud native solutions. These cloud native solutions are very important to run our application because everything is managed by cloud. Cloud is telling that I will take care of everything. You name it and I will give you. You want to use AI? I have AI models. You want to use SQL? I have a SQL server running. You want to use Redis? I have it. Okay. You want to use networking? I have it. You want to apply security? I can give you security. Okay. So you name the solution and they have it. You want storage? Okay. Initially storages were in real hype. So you want storage? I will give you the storage. Cloud is telling, don't go anywhere. Use my solutions. I will do everything for you. Okay. And this is what it says. That is why we use cloud, because cloud is giving us all the solutions right in one place. And that is what is cloud native solutions. Now, all the clouds, the question is, do we have to do, or are all the clouds different? Okay. Are all the clouds different? No, all the clouds are not different. All the clouds give you similar solutions. Okay. All the clouds give you similar solutions. Only the name of solutions is different. For example, if I was talking about Docker, okay. Now, to store this Docker image also, to store this Docker container also, we need some storage, right? If that Maggie cup noodles was a thing, a physical thing, to store thousands of these, we need a physical storage. Similarly, to store thousands of Docker images, we will need some storage, right? Where we can store this image or the container. So AWS gives us something called as ECR. I'm just talking about a solution. AWS gives us something called as ECR, Elastic Container Registry. Similarly, Google Cloud Platform gives us something called as Google Artifact Registry. So see, the names are different, but the job is the same. This is Elastic Container Registry. This is Google Artifact Registry, wherein you can store your images, right? Similarly, on Amazon for storage, for AWS on storage, you have something called as S3 buckets, okay? Storage buckets. Similarly, on Google, you have Google Cloud Storage. As simple as that. Google Cloud Storage, right? AWS gives you an AI model. AWS gives you an AI model called as AWS Bedrock. Google gives you their AI models, which is called as Vertex AI. Microsoft gives you their AI models, which is called as Microsoft Foundry. So all the clouds are giving you similar kind of solutions. Just the name of solutions are different. Okay. If you learn one cloud, learning other cloud technology will not be a big deal. Similarly, if you learn LangChain or LangGraph, which we are learning, using another framework like Crew AI or let us say Pydantic AI, this will not be difficult because you know how AI agents are built and how AI agents work. Similarly, you know what solutions you need and why you need those solutions. Provider doesn't matter, only the name of the solutions will change. All the providers give you the similar kind of solutions itself. Okay. And yes, that was a brief overview upon deployment and CI/CD pipeline. We can have a look over here as well. This is some image I have made. CI/CD pipeline, the last revision part. Code locally, push it onto GitHub. CI/CD triggers. So when CI/CD triggers, it does not build the image directly. there is some test cases coming into the picture. We will test our system first, Python testing, okay, PyTest. If the tests are passed, then only we will build the new image, or if tests are failed, we cannot build the new image, else the system will be disturbed. Build the container, push the image, and then deploy to cloud. As simple as that. And yes, we use GitHub Actions for this. I will come to this some other time. But yes, that was all about understanding deployment, and that was all about understanding CI/CD pipeline. And yes, that was the most simplest explanation of CI/CD and deployment lifecycle. See you in the further videos where we will start with the implementation of the same. Until then, take care. Bye bye. Live your life.